Welcome back. I've made it to the day 2, so congratulations to myself. And let's get started. Vamos. Oh no, I hate matrices. I know they are like the 2D version of array. They're twice as boring and half as interesting as an array. That's why I hate them. But let's not grieve over things we can't control and let's try to solve this problem. So we are given two binary square matrices and we can translate a matrix. That is, we can move a matrix to the right and to down, uh, and we can do this any number of times, and we keep filling the empty spaces with zeros, and yeah, so we can transform both the matrices or one. I think it doesn't matter because transforming both the matrix, we can convert the situation into transforming a single matrix, relatively. And after that we need to find such a transformation such that when these two matrices are put on top of each other, maximum number of ones overlap, and we need to find the largest overlap possible. Oh, I'm sorry. Okay. Oh, and the constraints are pretty weak, so n is 30. So I think brute force would work in this case because no matter how much transformation we do, we can think of a transformation as two starting points. Like if this is the starting point of this matrix, then the matrix would be something like this. These empty spaces would be filled with zeros, and if this is the starting point of the second matrix, that means I'm moving the whole matrix left by 2 units and top by 1 unit. So in that case, this would be the transformed matrix, and all the empty spaces would be filled with 0. So we just got to loop through these two starting points, which would be n square into n square, which would be n power 4, and in each transformation we just need to check number of ones present, number of ones overlapping, and we just need to find the best transformation possible. So even the brute force would work in this case, which would be n power 4, but I think we could improve. I don't know why, but I feel like we should use a sparse matrix. As you can see, in most of the cases, no, as we're transforming, in most of the cases there would be empty spaces, and in empty spaces there would be zeros, and we don't consider zeros in overlaps. So going through loop each and every time in which most of the numbers are zeros, it's a waste of time. Instead we could create a sparse matrix. Now a sparse matrix is, it's a really simpler uh, concept. So it is used when our matrix has mostly zeros. In this case, instead of storing the whole matrix, we can just store the non-zero values, in this case only number of ones, and we could create a sparse matrix of both the matrices, and then we could find a transformation. you know if you go back to your linear algebra, every transformation can be defined as an x translation, as a y translation, given that we are dealing with 2D matrices. So every transformation can be defined using two variables, x translation and y translation, right? So which we need to find a transformation x and y such that the number of overlapping ones are max. I think this would be a little more uh, efficient than our previous brute force method. Nevertheless, the time complexity would still be n power 4, like when all the numbers are 1, and in both the matrices, and the starting points are this and this. In that case the time complex would be same, but as we are using a sparse matrix, it in most of the cases amortized time complexity would be a lot better than our brute force solution. So then let's start coding. Then let me open up my PyCharm, and then let's click on the first problem, overlap, and come on, let's go. I like to remove all these stuff. I'm just using PyCharm so that because I can't afford a premium Leetcode subscription to get autocorrect, and I really suck not having an autocorrect. Okay, so let me create a sparse matrix of, no, instead of matrix, and let me call them M1 and M2. I love those names. So sparse M1. So let me have, so sparse matrix is simply it's a list of all the non-zero elements present in I think I can create a function, make sparse these puppet conventions. We should follow them. I love them. Okay. So I'm looping through the whole matrix. I don't know why I bought this new laptop and I often confuse a colon with a semicolon, and I'm still not used with this new keyboard, so it sucks sometimes. See, okay. So if if the current element of the matrix is 1, in that case I could add its coordinates in the sparse matrix, and at the end I can return that. Let me quickly create sparse matrix for both image1 and image2. So yeah, so once we have the sparse matrices, we got to now find a transformation such that we have the maximum number of overlaps. So how do we do that? One thing we could do is we could consider each one in the matrix 1 and each one in the matrix 2 as two separate as our starting points, and then we could try to transform the matrix such that these both overlap. Do you understand? So let us take this example. So I'm only considering only ones, not zeros. So let's say in this matrix I consider this one as my starting point, and in this matrix I consider this one as my starting point. Now what I try to do is I try to create a transformation such that this one and this one overlap. So for that, what do? I have to move this 1 unit up and one unit left, or this 1 unit right and 1 unit bottom. So relatively both are equivalent, and then once these both are overlapping, I think because out of all transformations, the best transformation would include at least one from the left and one from the right to overlap. So I'm just trying each and every possible transformation here between both the ones. I'm checking which one would be the best and which transformation would have the most overlapping ones. Let me try that. Okay. For x1 comma x2 in sparse matrix M1, for x1 and y1, and x2 y2 in sparse matrix M2. Overlap x1 y1 with x2 y2. The transformation should be the x1 minus x2 and y minus y2, because here we need to transform x. uh, the x would be the difference between the x coordinates, and y would be the difference between the y coordinates. So the transformation would be x1 minus x2, y1 minus y2. So this would be the transformation. And let me create another hash map which would contain default. Default is just like a dictionary, but it has some default values. It's like map in C++. Yeah. So this dictionary overlapping would store how many times we have got an overlapping one on a particular transformation. So this means, so as we have matched x1 y1 with x2 y2, which are both from sparse matrix, we are sure that there is one overlapping. So we are increasing the number of overlaps by 1. And then let's have a variable for answer. And answer would contain, we would keep maintaining a max answer for each and every overlapping transformation, and then maybe return the answer. I'm not sure if this works, but it looks good to me. Let's test this out. Okay. Default int. So we need to give a default value. Okay. Let me try to submit this on the website. It's a little more intuitive there. Oh, okay. So we're getting a wrong answer on the test case 1. Okay, so I'm getting an output of 4. Let me once print out this transformation overlapping map. Now that's why I love Python. We can keep printing anything we want. That's not possible in C++. We got to write a loop yourself to print that, but in Python it's automatic. Okay, so the transformation 0 0 is 4. So that it means that if we overlap, okay, I'm confused. Why is it 4? Is the sparse matrix correct? Check that. Zero zero. Okay. Why do you have the same sparse matrix for both? I don't understand. Okay. So I might have accidentally or hard coded this function, which you shouldn't do. So it shouldn't be image1, right? It should be matrix. Why weren't you telling me? Aren't you paying attention? Huh? Okay. Then it should work now. Yeah, it is working. Let me let us quickly think of any corner test case this might fail in. It looks good to me. Let's take a shot. Oof. Yeah. And the shot was worth it. And that's it for today, guys. If you like this video, like it, share and subscribe and share it to your friends. And if there are any suggestions, please comment down below so that I could improve for tomorrow. And yeah, see you tomorrow. Bye.